Okay, we'll start today's tutorial session. We'll solve some previous year's assignment problems and we'll have a discussion. So let's start. So the first question is the frame in figure supports part of the rod of a part of the roof of a small building. Tension in the cable is 150 kilonewton. The reaction at the fixed end E. So they are asking the reaction at this end E, fixed end E. So to calculate the reaction, we have to calculate the total force in the system. So what is the total force in the system? So let's see where are the forces acting. So first of all we can see, so the frame in question here is this frame. So this frame is holding this beam and there is one rope attached to it. So this rope has tension which is given. So this rope, what is doing is, what are the forces in this due to this rope? So there is one force acting around at this point B, which is due to the tension in this rope, and so the same rope here at the D point in the pulley, it is pivoted. So there will be another forces acting at D like this. So we have to calculate all the forces. So first of all, let's calculate the force due to the beam. So let's call it force beam. So what it will be, so we can see we have 20 kilonewtons, 1 2 3 4 20 kilonewtons forces acting along this direction. So let's define some coordinates. Let's see, this is x axis and this is y axis. Okay, so if beam becomes, there is no component along x direction but on y direction, 4 into 20 kilonewton and minus y cap direction. So this becomes 0 comma minus 80 kilonewton. Okay, this is force at F beam. Next, let's find out what is the force at F at this pulley. Okay, so to find out the force at this pulley, so remember this is y, remember this is y direction. So if you look at this, so there is one force acting along this direction and this direction. Let's say this is u cap. The unit vector along this direction from D to B is u cap and unit vector along D to F is v cap. So force at D, at the location D, is some mod F u cap plus some mod F v cap. So we write mod F as F u cap plus v cap. Now we have to find out what is u cap and v cap, because so this force is nothing but the tension in the rope, u cap plus v cap. Okay, so now this u cap is in the direction of D to B. So u cap is, we can write as vector dB, which we can write as vector dB minus vector D. So what is B? B means basically OB. So we can write B as, in x direction we go minus 1.8, 1.8, 1.8. So 3 times 1.8. So this becomes minus 3 times 1.8 meter, and in y direction we go along this much, which is 3.75 meter. So 3.75 meter. So this is B. Let's write, okay, so let's write it differently. So okay, so here B is this, which is minus 5.4 comma 3.75 meter. This is B. And what is D? So D is x, in the x direction it is 0, in y direction it is 2.25 plus 3.75. so 0 comma 2.25 plus 3.75 meter, so which gives 0 comma 6 meter. So dB becomes B minus D, which is basically minus 5.4 comma minus 2.25 meter. Okay, so now mod dB is root over 5.4 square plus 2.25 square meter, which gives you around, if you calculate it, it will give you 5.85 meter, around this. So we get U cap is dB by mod dB, which is minus 5.4 by 5.85 comma minus 2.25 by 5.85, this. So U cap doesn't have any direction, and we also need to find out what V cap is. So V cap, if you look at this, V cap, so vector F minus vector D, V cap is, let's write it, so V cap is vector F minus vector T. So vector F is, in x direction it is 4.5, y direction it is 0, so 4.5 comma 0 meter, and D we already know 0 comma 6, so V cap is F minus D, so 4.5 comma minus 6 meter. Okay, no, sorry, not V cap, sorry, DF is this. Fine. Now what is mod of DF? Which is root over 4.5 square plus 6 square, which will give like 7.5. so V cap becomes DF by mod of DF, which is basically 4.5 by 7.5 comma minus 6 by 7.5 meter. Okay, okay, so what we got here now we have to find out this. Okay, so F of D, FD vector, so FD is what? Tension times U cap plus V cap. So tension times, we got U cap is minus 5.4 by 5.85 minus 5.4 by 5.85 plus this V cap 4.5 by 7.5 comma, the second component is minus 2.25 by 5.85, 2.25 by 5.85 plus, sorry, minus 6 by 7.5. So if you calculate it, this becomes minus 0.323 comma minus 1.18. Okay, so now T given 150 kilonewton. So if you write 150 kilonewton times minus 0.323 comma minus 1.18, which will give you basically minus 48.45 comma minus 177 kilonewton. So I have done these calculations already. You can I have already done it using a calculator, so I'm writing from that, and I'm not doing it in my mind to be specific. And if you can verify it using a calculator and any kind of calculator, like you can see 150 times 0.323 is 48.45. You can do it like this in any calculator and find out. So we got f of d. Okay, so one force we got f of beam, we already got it. Now f at d we got. Now there is another force which will act here at this point due to this tension balance of the load and the rope. So let's find out what is it. So look at this. So this force will act opposite to this u cap and will have magnitude of equivalent to the tension. Okay, so f at b, this becomes f at b, this becomes this tension times minus u cap. So tension is 150 and u cap is this 5.4 by 5.85, 5.4 by 5.85 comma, you can write it 2.25 by 5.85, 2.25 by 5.85. okay, f of b. So again kilonewton. So now if you multiply it again, I'll do it from my notes, which becomes 57.7 kilonewton. Now we have the final force. So one force is this, another force is this, and the third force is this. Now let add all of them. So F total equals F beam plus FD plus FB, which gives you 0 comma minus 80 plus minus 48.45 comma minus 177 plus 138.46 comma 57.7 kilonewton. So if you do the sum, did I do it correctly? Sorry. Yes. So 138.46 minus 48.45, you get around 90.01 comma, the other part is minus 199.3 kilonewton. Now you were asked that the reaction at the fixed end D. So reaction will be equal and opposite to this force. So let's say a reaction at the fixed end E is the opposite, minus F total, which is approximately minus 90 comma 200 kilonewton. So this is our answer. So let's go back. Yes, this is the answer. Okay. Okay, so next question, man raises a joist, a type of beam which is basically this, by pulling a rope. So he's pulling a rope like this. Assuming G equals this, calculate the rope, the tension in the rope. So let's break it down to a free body diagram. So let's write it like this. This is the base. Oops. And this and this. Something like that. It's not exactly horizontal. I couldn't draw it horizontal. So this is the base, and we have a joist or a beam. So beam, this point is A, this point is B. Now there is a rope and a man is standing like this and holding this rope and pulling around like this. So the tension here is T, and the rope is the beam is, mass of the beam is 10 kg, and the length of the beam is 4 meter. So let's say this whole is the length L, which is 4 meter. And what else is given? There are theta 1 is given, which is 45 degree, and theta 2, let's say this one, is given 25 degree. Now we are asked what is the tension T in the rope. Now you see this rope, this beam has a mass, so it has a weight. So this weight is, for that this weight, it is trying to fall like this, and this man is pulling it like this. So the man is pulling it like this, and it is trying to fall like this. So there will be a balance of torque here. So the man is giving some torque here, and the rope is, the beam is giving some torque here. So to find out the torque of this beam, we assume that the weight of this beam is acting downwards from the center point. So if this whole thing is L, so this part is at Ly2. Okay, so from Ly2 it is acting downward. Let's name this point as P. Fine. So now let's calculate the torque of the beam. So torque of the beam will be so this length cross the force due to gravity. So it will be, let's do it in a color. Tau B is vector BP cross the force due to gravity, Fg. Now so this force, gravitational force, means this force, it is acting along this line, this mg. So what is the angle? So this we can write as mod of bp times mod of fg times sine the angle between bp and fg. So bp is like this, so bp is like this, and force of gravity like this. So the angle between this is this angle. So how to find out this angle? So we have to want to find out this angle. So this angle from this triangle, it's a this angle is 90 degree, this is theta 1, so this is 90 minus theta 1. So we get this to be 90 minus theta 1. So we find that this angle is sine 90 minus theta 1. So it becomes BP Fg cos theta 1. So the cos theta 1. So in which direction it will be? So it is perpendicular to the plane. Let's write it like this. So this is the first torque. So if we write mod, let's write it like this. So the amplitude of the torque. Okay, now what is the torque given by this rope to this? So given by this rope at this point B. Okay, so now tau, let's say man, m. so which will become this AB, this AB cross this. So the man is holding this whole thing. The gravitational force was acting from the midpoint, but this man has to hold the whole torque due to the whole beam. So it will become AB cross the tension T. Okay, now this becomes ABT sine angle between this and this, so which is basically theta 2. Now from the if it is at equilibrium and man is able to hold the rod, this becomes ABT sine theta 2 is equal to BP FG cos theta 1. So the tension becomes BP FG cos theta 1 by AB T T is there sin theta 2, which is what is BP. BP is half of this length, so L by 2 FG is mg cos theta 1 by AB is L sin theta 2. So L gets cancelled out, so mg cos theta 1 by 2 sin theta 2. So m is 10 kg, g is 9.81 meter per second square, cos theta 1 is 45 degree by hello can you hear me? Hello. Yes,
Good evening, sir. Good evening, sir.
Yeah, can you hear me, right?
Yeah, sir.
Okay, so I just started actually. I just solved one problem,
Yes.
and in the middle of the second problem, since no one has joined, I actually started. I can quickly go through the first problem for you.
Right, sir.
So you see here the question is, so there is a frame,
Yes.
this frame, and there is a beam like this. Okay, so the beam has different masses and mass distribution is given. So 20 kilonewton, 20 kilonewton forces it is giving at different points, and there is a rope at B which passes from this point to this point. Okay.
Yes, sir.
So the question is the reaction at the fixed end E. So the reaction here we have to find out. So to find the reaction, that we have to find out the total force this beam is feeling. Whatever the total force the beam is feeling, there will be a reaction, equal and opposite reaction at this point at the ground. Okay. So we need to calculate what are the different forces. So first of all, we can say that this beam has a total force acting along this direction. So this beam's force is so in terms of matrix notation or vector notation, we find that and along x direction, so we take this as x direction, this as y direction. So along x direction there is no force, and along y direction we have 420 kilonewton forces. Okay, so this becomes the force at due to beam becomes 0, minus 80 kilonewton. Next is at this, so due to this rope, this D point will feel some force due to the rope at the passing through it. So this ropes, so the total force will be mod F. We took this direction as U cap and this direction as V cap. So mod F u cap plus mod f v cap. Okay, so mod f is basically the tension in the rope which is given, tension in the cable which is given, and it becomes u cap plus v cap. So we have to find out what is the u cap and v cap. So u cap, if you look at it, u cap becomes, so we took from d to b, so d to b, so d to b means vector b minus vector d, right? This you understand, right? So we can write this vector as this ob minus od, like this. We are writing this b minus d. Now this b point, if you look at it, so along x direction it goes minus 1.8, minus 1.8, minus 1.8, so minus 5.4, and along y direction it goes till this point, which is 3.75. so we wrote this as b vector, and the d vector goes as, in x direction it does not go anywhere, in y direction it goes 3.75 and 2.25 meter. So we write this, we calculate dv vector, from there we calculate mod of dv, and we get u cap like this, something like this. Now to find v cap, we write it as vector f minus vector d. We define v from d to f, so we write f minus d, which is, similarly you can find out what is f is 4.5 comma 0 and d is 0 comma this. So we find df, we find mod df, so we find v cap. So f at d, so here force at d, which we found tension times u cap plus v cap. So we find this to be looking like this. Okay, so and there is another force acting in the system which is at this point b, due to this rope and this beam's balance. So this is acting along minus u cap direction, so u cap we have defined along this direction, so that force is acting along this direction, and the magnitude of the force is the tension in the rope. So the last force T times minus u cap. So we already found u cap, so we found this. Now the total force is this beam force, the at the point D force, and at the point B force. So we added everything and we find this. So the reaction will be negative of this, so minus 90 comma 200 kilonewton, and this is the answer. Okay, next we are solving this problem where it is stated that this is a beam and there is a rope. So one man is pulling the rope like this, and this beam wants to fall due to gravity. You have to find out the tension in the rope, how much tension how you have to put, or how much force you have to push. So we so there will be a torque balance. So there will be a torque due to its own mass due to gravity at this point B, and there is a tension. This tension will give another torque to this system. So the gravitational torque is BP. So this BP, why P because it is at the midpoint. So the gravitational force we take acting at the midpoint. So BP times Fg times sine. So this angle is given theta 1, and BP and Fg has an angle 90 minus theta. So if this is theta 1, this angle is 90 minus theta 1. So BP Fg sine 90 minus theta 1, which is cos theta 1, and the torque due to this man's pulling is this AB cross this. Okay, so AB cross T, which is ABT sine theta 2. Now we have balanced these two out, and T is coming out to be, and here we are. So T becomes, M is 10 kg, G is 9.81, cos 45 degree, 2 sine theta 2. Theta 2 is 25 degree. So if you calculate it, the tension comes out to be 82.06 Newton around. So I have already calculated it beforehand, so you can verify it. So if you find this, so you get kg meter per second square, which is Newton, and this if you put sine 25 degree and everything, you get 82.06, which means this is your answer. Fine. Now next is in the figure of above question 2, the reaction at A is, so the reaction, we have to find out reaction at A. So to find out, same way to find out reaction at A, we have to find out the total force acting. Okay, so let's bring the free body diagram here also, and let's put it here. And what is the force? So there is one tension, so we can say that this tension, we can break this tension to components. Let's say this and this, right, in x and y direction. So this, if this angle is phi, then this is t cos phi and t sin phi. The force along x direction is t cos phi, force along y direction is t sin phi, plus mg, because there was an mg mass. So the total force, magnitude of the total force is t cos phi whole square plus t sin phi plus mg whole square. Okay, now what is the phi? The question is how to calculate the phi. So we have already given, so I am just extracting some parallels from this just a minute. Sorry for that. So let's draw another diagram from this diagram itself, like this. Okay, so this one is theta 1, this one, sorry, this one. So this whole angle is theta 1, right? This whole angle is theta 1. Now from this whole angle there is this part which is theta 2, so there is another part which is theta 2. So what is this angle then? Phi. Phi becomes theta 1 minus theta 2. So we found phi. So F total is T, so theta 1 was 45 degree and theta 2 is 25 degree. So phi becomes 20 degree, right? And tension was, we already found 82 Newton. So tension is 82 Newton, 82 times cos 20 degree square plus 82 sin 20 degree plus mg. M was 10, g was 9.81, so 98.1 square. So if you do the calculation, I have already done it, I'll just write it down, which becomes 147.8 Newton. So around 148 Newton is your answer. You understood, or did I go too fast? Hello?
Hello. Yes, sir.
So any questions, or did I go too fast?
Yes, sir. I am following this, but sir, there is somewhat confusion rising, sir.
Yes.
You are saying that phi is equal to theta 1 minus theta 2.
Yes.
Theta 1 is this.
Mm-hmm.
So this can become, whole can become theta 1. Right.
Yes.
This is the alternate angle.
Yes. So okay. So my
Ye-
drawing
uh,
is not very good. I'll draw again.
yes.
So let's
Yes,
say
yes.
this.
Sir, just a minute. I want to ask that during exam, how can we can see the cos 20 degree and such and such? We can use electronic calculator
I think there will be.
here.
Yes. I'm not sure, but I think there will be. If not, then there will be like questions where you would not have to use it. Don't
Sir,
think.
during exam, we have to solve the problem in such a subjective manner, or we have to answer just like we are giving in the assignments.
You will be asked this numerical choice questions, right? Multiple choice questions.
multiple choice.
Yes, there will be multiple
uh,
choice questions.
Multiple choice paper maybe on the computer seat or
Okay, so
on the paper.
I'll have to verify this. I'll verify this and let you know like how the exam will
Yes,
go.
yes,
Is it
very thanks a lot.
usually it is MCQ? Hold on, I'll write it down for myself. Uh,
Yes.
hmm, okay, so I'll have to verify this. Usually, like from previous year, some other course I was TA, there was it was multiple choice. For this course, I am have to check.
Yes, yes, thanks a lot.
Okay. So so you see this is the base theta 1 angle. So and the rope is, so you this see this pink line. So this pink line and this base line are parallel actually.
Sir, are you following Hindi, if
Yes,
I
yes,
can say
you
something?
can say in Hindi, no problem.
यस एक्चुअल में सर जो ये मैं नोटिस कर रहा हूँ ना, जैसे मैंने जो फर्स्ट और सेकंड असाइनमेंट अटेम्प्ट किए वो
हम्म,
मेरे लिए बहुत इजी लगे,
हम्म,
लेकिन थर्ड असाइनमेंट में
थोड़ा
मुझे प्रॉब्लम ज़्यादा आई।
यस।
और उसमें मेरे जो है वो 3-4 क्वेश्चन ठीक हुआ और
हम्म,
क्वेश्चन मेरे गलत हो गए, 5 क्वेश्चन गलत हो गए, 3 क्वेश्चन
ओके।
ही ठीक हुए। फोर्थ असाइनमेंट में मुझे और ज़्यादा प्रॉब्लम आ रही है, क्योंकि ये जो कंसेप्ट है ना, जैसे रोप वगैरह, ठीक है मैं अंडरस्टैंड कर जाता हूँ कि रेजोल्यूट करना, रिजॉल्व करना है इसको, लेकिन जैसे ड्यूरिंग सोल्यूशन या जैसे बीच में कोई ना कोई प्रॉब्लम, कहीं ना कहीं मिस्टेक हो ही जा रही है। तो मुझे तो लग रहा है कि इट इज नॉट नॉट पॉसिबल
No,
during exam, because there is somewhat pressure na. Otherwise during simple hours it may be possible. I am discussing just my problem na,
exactly,
which I
I
am.
completely understand. देखिए so अगर कोई करके दिखा रहा है सामने, then it is easy to understand,
Yes,
right? But when you are doing it alone and also in an exam, then it is difficult. तो वहाँ पे
yes sir.
प्रॉब्लम हो जाता है। सो इसका आई डोंट नो व्हाट इज द सॉल्यूशन, ओनली थिंग इज यू हैव टू प्रैक्टिस अ लॉट। सो हम लोग जब किए थे, हमारे जब था कॉलेज में, देन दैट वाज ओनली सॉल्यूशन के बहुत सारा अलग अलग बुक्स से प्रैक्टिस करना होता था। लाइक जस्ट द प्रीवियस ईयर सॉल्यूशंस माइट नॉट बी इनफ।
नहीं एक्चुअली में मैंने, जैसे मैं फिजिक्स बैकग्राउंड से था, तो मैंने इसका न्यूटोनियन मैकेनिक्स लिया। मैंने सपोज किया था कि इतना मतलब जैसे अभी मुझे जो आप करवा रहे हैं, जब आप करवा रहे हैं तब तो मैं फॉलो कर पा रहा हूँ,
एग्जैक्टली
लेकिन
एग्जैक्टली हाँ।
जब मैं सोल्यूशन करता हूँ तो मुझे कहीं ना कहीं कोई मिस्टेक हो ही जाता है, फिर मेरा आंसर जो है ना दैट डजंट मैच में मुझे। मैं थोड़ा सा हेल्प लेता हूँ, नेट की लेता हूँ, चैट जीपीटी की ले रहा हूँ, बट मुझे लग रहा है कि आगे वाले असाइनमेंट तो नेचुरली और टफ आएंगे फिर इस हिसाब से, क्योंकि
डिपेंड करता है, हाँ
अभी
हाँ हाँ।
50% कवर हुआ है, फोर्थ असाइनमेंट हुआ है, तो फिफ्थ सिक्स सेवन्थ में एट्थ तक पहुंचते पहुंचते तो नेचुरली डिफिकल्टी लेवल तो बहुत ही नहास हो जाएगा।
हाँ हाँ, डिफिकल्टी लेवल इंक्रीज हो रहा है। अभी तो प्रॉपर इंजीनियरिंग प्रॉब्लम्स कर रहे हैं, दीज आर नॉट
एक्चुअल
बेसिक।
में मैं ये नोटिस कर रहा हूँ कि इंजीनियरिंग स्ट्रक्चर पे ज़्यादा स्ट्रेस दे रहे हैं,
यस यस
और
यस।
मैं एक्सपेक्ट कर रहा था कि जैसे जनरल लेवल पे आएगा इसका
हाँ
ना,
हाँ हाँ
बट दिस इज टोटली रिसर्च लेवल पे लग रहा है मुझे तो सर।
हाँ। इस बीटेक सेकेंड या थर्ड ईयर वहाँ पे लाइक मैकेनिकल सिविल उस
हाँ
डायरेक्शन में हम लोग भी फिजिक्स में इतना नहीं किए। हाँ, हम लोग जब फिजिक्स बीएससी किए ये सब प्रॉब्लम हम लोग नहीं किए थे, हम लोग दूसरा डायरेक्शन में
हाँ,
चले गए थे।
बीएससी में नहीं आता है ना सर, मैंने भी बीएससी
बीएससी,
किया है
हाँ
ना।
बीएससी में नहीं आता, दीज आर फोकस टुवर्ड्स
हाँ
इंजीनियरिंग मोर। I was also
सर
struggling to solve before you, like I
नहीं नहीं,
solved it before you.
मैं सर एक्सपेक्ट करूंगा कि आप अपना मुझे फ़ोन नंबर वैसे या स्क्रीन पे दे दें, तो मैं कई बार कोई मुझे प्रॉब्लम आएगी तो मैं कॉल कर सकता हूँ सर आप।
कॉल कर सकते हो, you can email me here. You email me, I'll share it there, because if this thing
यस,
goes
मेल
to
कर दूंगा सर, ठीक है, मैं मेल कर दूंगा।
हाँ
ये तो अपन हमारे लेक्चर, आपका लेक्चर तो हमारी स्क्रीन पे रहेगा ना,
हाँ हाँ,
जब भी
देखिए
हम जाए।
देखिए यहाँ पे ईमेल लिखा हुआ है, ठीक है।
हाँ
ईमेल में
ठीक है,
आई
ओके
कैन
ओके,
शेयर माई फोन नंबर इन द ईमेल, बिकॉज दिस विल गो टू यूट्यूब, दिस होल
यस,
रिकॉर्डिंग, दिस इज गेटिंग
डजंट
रिकॉर्डेड।
मैटर सर, डजंट मैटर,
हाँ
कोई
हाँ,
बात नहीं सर।
सो यूट्यूब में
मैं
मैं फ़ोन
मेल कर
नंबर
दूंगा
अभी
अगर जो
देना
भी।
नहीं चाह रहा हूँ, हाँ इसीलिए मैं
राइट राइट,
हाँ हाँ
ठीक
ईमेल
है सर,
करना इस मेल पे, हाँ इट्स हियर।
ओके।
This is the email, my official ATH email ID. You can email it here.
ओके ओके सर,
Okay. Okay. So क्या बोल रहा था, हाँ, so I was talking about, so this is also theta 1. Now the rope here is from like this. This is the rope. So this pink line, these two lines are the parallel line, and this is the rope, and this is said to be
यस,
theta 2. So the whole thing is theta 1, this is theta 2, so only this part is theta 1 minus theta 2. Okay.
राइट सर,
Hmm. Okay, so let's go to next question. For the beam shown in figure, reduce the system of forces by an equivalent force, its magnitude and direction in vertically upward direction, or whatever. So we have to write the mean force. So this is very simple, but it's a bit tricky question. Tricky, not tricky, but you feel like it could be, there could be too much stuff going on, but it's not. It's simple. You have
यस,
to, this is x direction, this is y direction. Now uh, you have to like it's like you have to calculate the equivalent force. So you just take the sum of all the forces. So there is no force along x direction, and only force is along y direction. So just total force becomes 0 in x direction, and y direction is 150.
100,
600 is
250,
minus 600, this is 100, and minus 250 Newton. So this becomes, this 250 250 cancels,
0 minus 600,
100 Newton. So minus 600 Newton y cap. This is the correct answer. This is simple, really simple question.
this is very simple.
But there is a follow up, I guess. Yeah. For the beam shown in figure 4, the net moment about point B and plus z cap direction is. So you have to calculate the net moment about this point B. So moment is nothing but torque, and you have to, like, it's R cross F basically. So there are some, so what will become, there will be sum of all the moments, all the forces. So for this first 150 Newton, you have to take the whole length, okay, and this vector from B to this joining will be along this direction, and the force is along this direction or this direction. So always the sine theta will be 90 degree, right? So so this is 1, so we can just write it is sum of R times F. So for first thing it is AB times F1 plus, so B, let's say this is B, so BP times F2 plus B, let's say this is Q, so BQ times F3 plus, there is nothing, so 0 for this force. So AB becomes 150 times, no sorry, AB becomes, AB is 2 plus, so this is 1.6 plus 1.2 plus 2, that is AB, times 150 plus BP, so BP is this, so 1.2 plus 2 times 600 but with a negative sign, plus BQ is 2 times 100 Newton meter. So I think you can calculate this. I did the calculation beforehand and I got minus 1000 Newton. So Newton meter, sorry. So yes, so in minus z cap direction. Why minus z cap direction? So if it, So this is your BA vector and this is the positive y cap we took. So if you curl your fingers, you get this is along inside the paper, and this is z cap along outside the paper. So the direction will be inside the paper. So you can absorb this minus sign and Newton meter. This is the answer. So in this question it is given twice unnecessary. Oh sorry, no, this is in y cap direction. This would not be the answer. This is the answer. Fine. Okay, so I'll go to the next question. So calculate the force reaction at support A. So we have to calculate the reaction force. So reaction force at the support A of the built-in beam, which is subject to the sine wave load distribution. Very important, sine wave load distribution, with omega x is the external load distributed. So the load distribution have a profile as omega x, which is some kind of sinusoidal sum x, sinusoidal x, and given that omega at L by 2 is omega 0, this 2 is given, you have to calculate the reaction. So this is load distribution, means this is the force. Now we have to calculate total force. So this means at small dx, this is the force is getting applied. So how do we include this 2? We can write omega x to be omega 0 sine pi x by L. If you ask how did I write this, it's for like if you know about this kind of functions, you can intuitively write it. Otherwise you can take any kind of system and any kind of form and get it. I'll explain what I'm trying to say. So our hint is we have to have omega at L by 2 equal to omega 0. Let's say this is satisfied or not. So at x equal to L by 2, omega 0 sine pi L by 2 L. So L cancels, pi by 2, which is omega 0, which is satisfied. Okay, so I can argue that this form satisfies the given condition omega at L by 2 equal to omega 0. If you don't know how to do it, you have to start with some constant times sine some dx. Okay, from here you have to satisfy at x equal to L by 2 a sine bl by 2 is equals omega 0. This you have to satisfy, and then you can find it out. You can reach to the same conclusion. Okay, so what we have now is omega x equals omega 0 sine pi x by L, right? This is the load distribution. So this is force acting at every small element dx. So the total force is, we integrate this omega 0 sine pi x by L dx from 0 to L, x equal to 0 to x equal to L. So you get minus omega 0 L by pi cos pi x by L 0 to L. So what is it? You get cos pi, which is minus 1, minus cos 0, which is 1, so 2. So you finally get 2 omega 0 L by pi is the total force. So what is the given? This is the answer, total force. Understood? Any question? Okay, let's move on. Next two are very simple questions, and simple means it's we have to discuss it. So the external force P, there's an external force P is applied at point D to the mechanism shown in figure. Determine the number of degrees of freedom given in the mechanism. So you have to determine number of degrees of freedom. Do you know how to find out a number of degrees of freedom? So if you look at this system carefully, if you apply a force like this, what will happen is this, so this thing will move and this will become like this and this, and the whole thing will, yes, you're saying something?
Yes, sir.
So do you want to try this? So it's as the number of degrees of freedom given in the mechanism. So to find out number of degrees of freedom, that means which coordinates can move freely. Why are people joining now? Hello?
Yes, sir. Yes, sir.
Yes. So hold on. Munal, can you hear me? Yes. Was it said 4 or was it said 3 or before 3? Today's class timing? Okay, anyway, so we have only 2 questions left. That's what I'm asking. So it will end pretty quickly. So whoever is joining now, you can go back to the YouTube videos and find out the earlier discussion which we had here, and this PDF will be shared to you via the Google Drive. Please refer to that. And from next Saturday it will be 3 to 5, the regular class. This is an extra class because I missed one Saturday. Okay, so here the number of degrees of freedom. To find out number of degrees of freedom, you straight up look which arms can move freely. Okay, and which arms can move freely here. So if you pull it, you see first of all this whole arm, this is a big joint, so this part is joined and this is also joined, and from this A to F is one arm. Okay, so A to F is one arm and E to B is another arm. Then what is the other arm? That is BD. Yes, did someone ask anything? Okay, no, I think not. Okay, so but they are connected. These arms and these arms are connected via C, and DB is connected, and DF is also connected. So you can imagine, so I can draw it here. So if you pull it like this, the whole thing will become something like this, right? So tough to draw something like this. I can't draw. So you can imagine, right? If you pull it, so none of this can move freely except this one arm. But what I mean by that this will make these two move, which will make this move, and because these two are connected, the whole thing, so these two's movement are not independent of each other. So only thing that will change if you pull this P is via this theta 1, sorry, theta. So nothing else will change. So the degrees of freedom will be 1. because everything is dependent on everything else.
एक्सक्यूज मी सर, जैसे डिग्री ऑफ फ्रीडम होता है इंडिपेंडेंट बेस टू कंफ्यूजन ऑफ द
Can you
मैकेनिकल सिस्टम
can you repeat?
एंड जैसे degree of freedom
Hmm.
are the number of independent ways by which we can describe the configuration of a system.
Yes, number of free coordinates.
Independent,
Independent and
independent
independent
ways or the
coordinates.
coordinates required to
Yes,
specify the
yes,
configuration of a system.
yes.
So here, sir, you are saying that if we applying the force at point D, then during the application of force, the
Hmm.
force acting at point B and F are uh,
Not same.
led to.
I'm not saying
Uh,
same. If you represent, if you say due to this
uh,
point P, how much this theta is changing, you can actually
mm,
calculate all of the others.
yes,
Right, you don't need any other information to find out that how the B moved, how the F moved or how the E moved. और किसी का ज़रूरत
yes,
नहीं है, ओनली दिस थीटा का अगर तुम चेंज बता दो, फ्रॉम दिस थीटा
yeah,
से तुम सी का चेंज बता सकते हो, फ्रॉम दिस सी का चेंज यू कैन सी दिस एंगल कितना चेंज होगा, फ्रॉम दिस बी एफ डी एवरीथिंग यू कैन से चेंज. दैट इज वाई वन
yes.
डिग्रीज ऑफ फ्रीडम.
So here the degree of freedom is one.
One, yes.
Final answer is one because at last, sir, but we can say in conclusion, sir.
Conclusion is that the independent variable here is only theta, and all the
Yes,
other joints are dependent on each other. So D, B and F
yeah,
are all joint depending on each other, and E depending on C, C depending on A. So everything is depending and goes back to these points, this arm. So you have to find out which are the
in
independent.
such type of problem, we have to just to see that
Yes, yes.
uh, there is
Hmm.
any change in theta, r theta and phi.
It's R is not necessary. That is, it's a fixed
Yes,
length, right?
yes,
It's a fixed length, and
a
phi,
fixed length.
yes, and phi there is no movement along inside or outside the page because of the
Okay, yes.
beam.
Now I am following, sir, because I am just
Hmm.
in my views that we have to consider all the coordinate. The
Hmm.
r and phi are not changing, but
Hmm.
there is change in only theta.
Theta exactly. Yes. Yes.
Uh,
But there could be some cases where this B, let's say, it can move independently. Like it will
yes,
depend on A, but there is something else which can make this B. Let's, for example, I'm saying that B also can have a independent movement. Then that will be another degrees of freedom.
yes. Sir, how zero degree of freedom is possible? Example
Nothing
is
can
there
move.
some example
Nothing can move. It's a fixed system. Then there will be zero degrees of
for the
freedom. Let's say
for the fixed system, it is
yes.
there is not any rotation or there is
Nothing. Let's say
not
there is a
any
rigid
change.
body. Let's say this is a rigid
Yes,
body, and you pull it like this, and you fix this, and you pull it like
uh,
this. So it can't
yes,
move. This is also rigid, right? And you are not
yes,
rotating or translating anything. You want to stretch it, but a rigid body, by principle, it cannot be stretched. So that in this system there will be zero degrees of freedom. Nothing is moving. So this, you said R and phi. So in R and phi direction, those degrees of freedom become zero because of the rigidness of the system.
sir. Sometime I in my views, na, there
Hmm.
is a somewhat confusion lying there during solution of the problem. Na,
Hmm. Hmm.
whenever we are discussing with you or
Hmm.
other person, then
Hmm.
these concepts are
Hmm.
somewhat
Hmm.
कुछ लगता है कि ये सही हमारे
हाँ,
पास
थोड़ा
कंक्लूजन मिल रहा
कंफ्यूजिंग
होता
लगता
है
है. हाँ हाँ, ये सब.
बट जब हम
हाँ
लोनली काम करते हैं, लोनली इनको ये करते हैं, तो देर इज सम बट
हाँ
कंफ्यूजन
हाँ हाँ
हमारे
हाँ
दिमाग में आता है कि यहाँ से, क्योंकि प्रैक्टिकली सर
हम्म
पॉसिबल नहीं होता ना। एक्चुअल में
हम्म
क्या है कि ये सिस्टम में हमें जैसे लेबोरेटरी में मिले या ये है, उसमें हम
हम्म।
देखें, अप्लाई करें ना,
हाँ, थोड़ा
मतलब
इमेजिन करने
प्रैग्मेटिज्म
में
बेस्ड,
प्रॉब्लम होता है।
तब ज्यादा
हाँ
पॉसिबल है
हाँ
मुझे
हाँ
लगता है।
हाँ। एक्चुअली ये वाला प्रॉब्लम तो है, लाइक थोड़ा एक्चुअली क्या होगा इमेजिन करने में कुछ कुछ सिस्टम में प्रॉब्लम होता है।
हाँ हाँ
वो यू हैव टू लाइक कीप सॉल्विंग डिफरेंट डिफरेंट सिस्टम्स,
हाँ।
देन यू विल
एक्चुअली सर जैसे आप सपोज कर रहे हैं ना,
हम्म
तो आपकी सपोजिशन और मेरी सपोजिशन में थोड़ा बहुत डिफरेंस आ ही जाता है सर, ना
हम्म
चाहते हुए भी ना, क्योंकि थोड़ा सा मैंने नोटिस किया सर, मैंने मैंने एक्चुअल में पिछली जो असाइनमेंट थे उसमें पूर्ण प्रॉब्लम्स में मैंने बहुत मतलब डीपली स्टडी करने का कोशिश किया, और अल्टीमेटली आउट ऑफ 8 मेरे 3 ऐसा है, 3 क्वेश्चंस ही सही हुए। तो मुझे बाद में फीलिंग आया कि नहीं, इट्स नॉट पॉसिबल फॉर मी, बट
So you have to keep practicing. That is the only solution I can give you. Otherwise,
राइट राइट सर, यू आर राइट, यू आर राइट,
dip,
बिकॉज प्रैक्टिस तो होता
हाँ
है, वो तो नेचुरली है सर।
हाँ, डिफरेंट डिफरेंट
बट
सिस्टम सॉल्व करोगे तो जाके तुमको लाइक यू विल हैव सम इंट्यूशन डेवलप्ड.
यस यस सर।
डेविड मॉरिन आई विल सजेस्ट, ट्राई टू सॉल्व वहाँ की
लेकिन
एक्सरसाइज.
सर मैं सोचता हूँ ना, जैसे हमने ये जो कोर्स
हम्म
ज्वाइन किया है,
हम्म
दिस इज फॉर जस्ट द इन्हांसमेंट ऑफ आवर नॉलेज,
हम्म हम्म हम्म
नॉलेज को इन्हांस करने के लिए, लेकिन ये तो इस उस लेवल पे हमें ले जा रहे हैं जहां से हमने कुछ उसको मतलब
हम्म
प्रैक्टिकल वे में हम, मतलब प्रोजेक्ट वे में, रिसर्च वे में देना चाहें। मुझे लग रहा है हम आउट ऑफ रीच जा रहे हैं सर,
हाँ,
जो मैंने मतलब
थोड़ा
एक्चुअली स्वयं के मैं
वीक थ्री
हाँ
वीक
जी।
फोर से थोड़ा जा रहा है. हाँ. हम्म,
एक्चुअली स्वयं के जो जैसे
हाँ.
जब ये स्टार्ट कर रहे हैं तो सर स्टार्टिंग में बिल्कुल सिंपल आ रहा है, जब हम
हम्म
एक्सपेक्ट कर रहे थे आगे
हम्म
चले आगे, लेकिन जब ये लास्ट में जा रहे हैं और विद इन
हम्म
यू कैन एक्सपेक्ट दैट कि विद
हम्म
इन 3 months
हम्म 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 हम्म
इट्स नॉट पॉसिबल टू गो इन सच ए एक्सटेंट ना, ये इतना
हम्म.
ज्यादा कर पाना मुझे लग रहा है कि मुश्किल हो जाएगा
मुश्किल
सर।
मुश्किल होगा, मुश्किल होगा, डेफिनेटली
हाँ,
मुश्किल होगा, बट स्टिल ट्राई
अगर
जितना
सही
हो
ढंग से
सके.
सर देखो ना,
हाँ.
आपसे मैं इसलिए शेयर कर रहा हूँ कि
हम्म
एक देखो कोई भी चीज है ना, जिस चीज
हम्म
को हम मतलब एक प्रैक्टिकल, ये एक ऐसा नॉलेज है, जैसे ये जैसे मैसिव ऑनलाइन कोर्स चला रहे हैं,
हम्म
ये मूक्स
हम्म
का है या स्वयं का है,
हम्म
तो मेरे आइडिया से तो ये होना चाहिए कि
हम्म
इसमें मतलब
हम्म
आदमी का जो है ना सर, वो क्योंकि
हम्म
ये सर एक्स्ट्रा एजुकेशन है,
हम्म
आई एम एनहांसिंग माय नॉलेज सर। बट
हम्म
अगर मुझे इतना नॉलेज एनहांस करना हो तो मैं आईआईटी लेवल पे, और उसमें लेवल
हम्म
का नॉलेज आप सब प्रोवाइड कर रहे हैं हमें,
हम्म.
आईआईटी लेवल का नॉलेज और
थोड़ा
एनआईटी
हाँ,
लेवल का
थोड़ा
नॉलेज हो।
ओवरवेलमिंग हो लग सकता है, आई कैन अंडरस्टैंड. थोड़ा
हाँ,
हाँ.
तो ये मैं उस हिसाब से सोच रहा हूँ कि
सी
कल
तुम,
को जैसे
आई
मैं
विल
सोचूं कि
सजेस्ट.
मैं कोई और कोर्स ज्वाइन करने का, चलो ये तो मैंने ज्वाइन किया है, लेकिन मुझे और का ज्वाइन करने का या किसी को मैं गाइड करूं, तो मुझे तो बहुत
थोड़ा
मुश्किल होगा।
नहीं मुश्किल मतलब यू हैव टू लाइक पहले देख लीजिए कि क्या क्या है उसमें प्रॉपरली, देन डिसाइड कर
नहीं नहीं
लीजिए.
सर,
हाँ
देखने पे तो सिंपल है सर, देखने पे
हाँ
देखो ना आप,
हाँ हाँ
जब
हाँ
इस टॉपिक पे हम जाते हैं सर, तो
हाँ.
आपके पास सिंपली क्या आता है,
हम्म
शुरू में न्यूटन्स का आएगा कंसेप्ट,
हम्म
फ्रिक्शन का कंसेप्ट आएगा, टॉर्क का कंसेप्ट आएगा,
हम्म
वर्क एनर्जी, टेंशन का है, बैलेंसिंग है, रेजोल्यूशन है, रिजॉल्व कर।
हम्म
लेकिन देखिए ना, ये जो प्रॉब्लम्स है सर, ये ऐसी प्रॉब्लम्स है जैसे आपने कोई ऐसा ब्रिज बनाना है जहाँ पे पॉसिबिलिटी नहीं है कि बीच में
हाँ.
आप पिलर दे सकते हैं, कहीं पे बीम दे सकते हैं, कहीं पे आप ये कर सकते हैं, हाउ यू कैन बैलेंस द, तो ये दिस इज द
ये
टोटली मतलब एक बहुत माइन्यूट और ऐसी इंजीनियरिंग है सर कि इतनी नो नो डाउट अच्छा नॉलेज है, मैं ये नहीं करूंगा, कहूंगा कि नॉलेज
हम्म
अच्छा नहीं है बहुत, लेकिन ये नॉलेज गेन करने के लिए तो वो वाले स्टूडेंट्स चाहिए जो मतलब उस लेवल पे, जैसे एनआईटी लेवल के हैं, यही है।
हम्म
अब जैसे मेरे जैसा कोई सिंपल एमएससी पर्सन है, या
हम्म
यूनिवर्सिटी से
हम्म
ग्रेजुएशन बीएससी किया है, एमएससी किया
हम्म
है, और मैं सोच रहा हूँ कि स्वयं के थ्रू मैं अपने नॉलेज को इनहांस करूँ, इस लेवल का नॉलेज इनहांस करके सर मैं +1 और +2 को टीच करता हूँ सर मैं, आई एम ए सिंपल टीचर ऑफ +1 एंड +2 क्लासेस। और मैं वहाँ पे इस नॉलेज को कैसे अप्लाई करूँ, मुझे वो कंफ्यूजन आ रहा है सर। अब ये नॉलेज तो बहुत एडवांस नॉलेज है सर, और मुझे ये भी नहीं लग रहा है कि ये है ना बनाए हुए। अब इस हिसाब से जैसे मैं सोच रहा था कि मैं कॉम्पैक्ट नंबर 3 पे लेना चाह रहा था, तो मैंने फिर आइडिया लगाया कि मुझे आई एम नॉट डिस्ट्रीब्यूट।
हेलो, आवाज़ कट रहा है। हेलो।
हाँ, मैं सर डिस्टर्ब तो नहीं कर रहा हूँ आपको,
नहीं नहीं
क्योंकि
नहीं
आपका लेक्चर बीच में मैंने रोक
नहीं नहीं, फाइन
दिया।
फाइन, एक्चुअली
जस्ट आई एम डिस्कस।
I have to finish it by 4:15, 4:20. I have a meeting actually.
यस।
It's fine fine, we just
यस
have one
यस।
question left. No problem, I understand. See,
हाँ
आपका
तो
आपका प्रॉब्लम है, समझ रहा हूँ, इट्स
हाँ
थोड़ा।
सर, मैं इसलिए
हाँ
आपसे शेयर कर रहा
हाँ
हूँ
हाँ।
कि इफ यू आर
हम्म
गोइंग फॉर द
हम्म,
टॉप्स ऑन टच वे,
हाँ हाँ
क्योंकि आप नेचुरली से जुड़े हैं, तो आपको आप ऐसे जो है ना अपने सजेशन दे सकते हैं कि
हाँ।
देखिए इसके साथ जो जुड़े हैं वो अब जो इंजीनियरिंग ग्रेड का person नहीं जुड़े सर आपके इसमें, जो हायर लेवल का आईआईटी लेवल का नहीं जुड़ेगा। मैं आपको
हाँ।
इस
हम्म
जैसे 5 ज़्यादा जुड़े थे,
हम्म
8-10%, 12-15 जुड़े,
हम्म
लेकिन जो उनकी थे ना टीचर, मुझे नाम सर था,
हाँ
उनके साथ, लेकिन डे बाय डे, क्योंकि जब नेचुरली जब डिफिकल्टी लेवल बढ़ेगा तो वो फिर
हम्म
कुछ आएगा तो वो छोड़ेंगे सर।
हाँ, मतलब जितना हो सके यहाँ से सीखना पड़ेगा, और यू हैव टू
नहीं नहीं,
एक्सट्रैक्ट।
नो डाउट सर, आई एग्री विद यू सर,
हाँ,
वो तो करना ही
नहीं
पड़ेगा,
ठीक है,
अब
नंबर या
ये है तो
असाइनमेंट्स के
करना
बारे में
पड़ेगा।
उतना मत सोचिए, जितना हो रहा है उतना करिए, आपके टाइम के हिसाब से करिए। नो
नहीं नहीं,
प्रॉब्लम,
मैं
उसका।
तो ये,
हाँ।
मुझे चिंता इस बात की हो रही है कि सर मैं एग्जाम भी देना है, तो एग्जाम क्या मैं कर पाऊंगा या नहीं कर पाऊंगा।
ठीक है,
दैट इज
उतना
द
भी
मेन टेंशन
उतना भी
सर।
सीरियस नहीं है। जितना सीख सीख पा रहे हैं,
अच्छा,
दैट इज ऑल। इट्स फाइन।
ठीक है
हाँ
सर, ओके, थैंक यू सर, थैंक
हाँ,
यू।
नो प्रॉब्लम। हाँ, प्लीज शेयर वट एवर योर प्रॉब्लम, एंड यू कैन ईमेल मी एनी टाइम। सेम एक और
यस
क्वेश्चन
सर।
है। हाँ। सो डिग्रीज ऑफ फ्रीडम ढूंढना है, दो डिग्रीज ऑफ फ्रीडम किस में ढूंढना है। सो इन द फर्स्ट क्वेश्चन यू कैन सी this is a ball and it is moving, so there is a p1 force here and p2 force here. Okay, so how many degrees of freedom will be there? So this p2 is moving, p1 is also moving.
नहीं नहीं सर, आई एम सिटिंग इन माय ऑफिस ना सर।
Okay okay okay।
आई एम सिटिंग इन माय ऑफिस सर, मैं अपना कैमरा ऑन करता हूँ सर, आप देखिए। मैं अपने ऑफिस में बैठा हूँ सर, चेयर पे बैठा हूँ,
नहीं नहीं, ठीक है
पीछे
ठीक है।
ये है मेरा।
नहीं नहीं, नो प्रॉब्लम। कैमरा ऑन करने की ज़रूरत नहीं है अगर
हाँ
आपको।
जी।
हाँ हाँ। नहीं, मैं पूछ रहा था कि अच्छा, मेरा भी ऑफ है। हम्म, तो
यस सर, आप
हम्म
सर प्रॉब्लम्स को ले रहे हैं ना सर, ये एक फोर्स F1 ऊपर से लग रही है,
हम्म
और सॉरी P1 और P2 लग रही
हाँ,
है।
सो पी टू यहाँ पे रोल है, तो ये मूव करेगा तो ये भी मूव कर जाएगा, राइट।
यस सर, यस।
सो
यस
ओनली
सर।
दिस एक्स, इसके हिसाब से यू कैन हैव दिस एंड दिस चेंज्ड, राइट।
यस यस।
हाँ, सो
यस
सो दैट मीन्स इट, दिस एक्स, दिस हैज ओनली 1 degree of freedom. Okay,
यस।
now see here, this is a double pendulum. You might have heard.
एक्चुअली सर, जस्ट आई एम ऑब्स्ट्रक्टिंग यू सर।
Yes yes।
जैसे हम यहाँ पे ये चेंज कर रहे हैं सर, इधर को ये पुल कर रहे हैं, तो ये एक्स एक्सिस में ये चेंज हो रहा है।
एग्जैक्टली।
तो सर जैसे ये, तो ये सर बाई एक्सिस के अलॉन्ग भी इसकी जो हाइट बढ़ेगी सर।
नहीं, हाइट नहीं बढ़ेगा
अब
इसमें।
जैसे, नहीं जैसे ये सर, ये सीधा जब होगा, जैसे मान लो
हम्म
इनक्लाइंड है ना सर ये,
हम्म
अब जैसे पुली मूव करेगी
हम्म so
तो ये पुली
it is confined।
ये पुली, तो ये, अच्छा ये कन्फाइंड है,
confined, हाँ,
ये
ये मूव नहीं कर सकता है उस साइड में।
प्रोटेक्टर हो फिर,
हाँ हाँ।
ये उसके लिए आर्क वगैरह ड्रॉ करने के लिए।
आपका
राइट राइट।
आवाज़ कट गया था। हाँ ठीक है। हाँ, तो डबल पेंडुलम में क्या है, यहाँ पे ये वाला जो हैंड है, ये दिस विल मूव लाइक दिस with the theta 1, and this can move with respect to theta 2, and these lengths are fixed, so it has 2 degrees of freedom. Fine. So two of the pendulums are connected, and everyone can move, both of them can move in their own uh, independently. Theta 1 and theta 2 can change independently. Okay. Similarly,
Yes.
this third one and this first one are quite similar. If you can define this theta, you can change this like what you can define what is the position of these points, how it will change. So this also has one. Fine. Just this theta, if one changes, everything else is changing. You can define this p1 p2's this location's position based on this theta only. Okay. And the last one is very simple. It is no matter whichever mass moves and whichever mass is higher, just this length will change. This length will change. Now if you know x, you know L minus x, and you can have everything else. Fine.
Yes.
Okay, so
Sir,
this
in the last one, there is a 1 degree of freedom, right?
yes, exactly. So only two, they are asking that which has the 2 degrees of freedom. This is the answer. So these questions, like it can be tricky at the first time. Again, I'm repeating, you have to practice different system, and you have to build an intuition.
Right, sir.
ये एक मैं जैसे बोला इंट्यूटिवली करने बोला अभी, देयर कुड बी लाइक यू कैन एक्चुअली write the forces, write the components, and convert one to another. Then you can find out that actually 1 degrees of freedom है. वो बहुत लेंदी कैलकुलेशन हो जाता है. इंट्यूटिवली करना है तो ऐसे करना होता है. ओके.
राइट सर, अगर आप कैलकुलेशन के बार बीच में मिस्टेक भी हो जाता सर.
हाँ, वो भी हो सकता है.
मैंने नोटिस किया सर.
हाँ.
और
Okay, that is all. So I have to finish it now, and we'll see. We'll meet again on Saturday, next Saturday.
okay, thank you sir, thank you, so nice.
Thank you. Yeah, great meeting you. Great talking to you.
Thanks a lot, sir. Okay.
Thank you.